Hi everyone, let's learn about hill climbing search. Hill climbing search is a goal driven informed search technique that focuses on the goal and not the path to the goal. It is also known as greedy local search. The goal is to reach the peak of a hill where it will then terminate. The search strategy of a hill climbing search is that it does not look ahead of its immediate neighbors of the current state. It does not backtrack because it does not maintain a search tree. It chooses randomly among the set of best successes if there is more than one. And it records only the state and the value of its objective function, which can either be a global maximum or a global minimum. Now let's look at how the algorithm works. First, it will pick a random point in the search space. Then, it will consider all the neighbors of the current state. It will choose the neighbor with the best quality and move to that state. This will repeat until eventually all the neighboring states are of lower quality than the current state. Finally, it will return the current state as a solution state. One problem where this search technique can be applied is the four queens problem. The goal is that no queen can attack each other. The heuristic value, h, is the number of pairs of queens that are attacking each other. In the example shown, h is currently 5, which means there are 5 pairs of queens attacking each other. If one queen is moved upwards, h becomes 2. And if another queen is moved downwards, h becomes 0, which means we have achieved our goal of no queen attacking each other. Let's look at another example. This time, it is the 8 puzzle problem. The goal is to convert the initial state to the goal state. The heuristic value, h, in this case, is the total number of misplaced numbered tiles. We assume the initial state as the start point. Currently, the number of misplaced numbered tiles is 5, as highlighted in red. There are 3 moves that we can do. Move 5 downwards, move 6 to the right, or move 7 to the left. Out of the 3 moves, moving 7 to the left would be best, as h will be reduced to 4. Therefore, moving 7 to the left is the selected move. Now, the option is either to move 8 downwards or move 7 to the right. However, 7 is already at the correct place. Therefore, it's best to move 8 downwards. h is now reduced to 3. Both 2 and 8 are already at the correct place. So, the best move is to move 5 to the right. Now, h becomes 2. Same goes, since all numbered tiles are already positioned correctly except 4, so we move 4 to the right to reduce h to 1. Finally, there's only one move left, which is to move 3 downwards. h now becomes 0, which means we've reached the goal. There are a few drawbacks that we need to pay attention to in hill climbing search. First is local maximum. Since it does not backtrack and only look at its neighbors, it might not find the highest peak in the search space, but only the highest peak nearby. Second is plateau, a broad flat region that gives the search algorithm no direction. It can be a flat local maximum from which no uphill path exists, or a shoulder from which progress is possible. There's also ridges. The algorithm may terminate itself when it reaches a ridge. This is because the peak of the ridge is followed by downward movement rather than upward movement. This makes it very difficult for search algorithms to navigate. Let's look at this example. All the moves that can be made will increase h from 1 to 2. And since all moves gives the same heuristic value, which move should the algorithm choose? This is how plateau can cause problems in a hill climbing search. Although with drawbacks, Hill climbing is still a very resourceful search technique, especially in solving huge problems. In real-life setting, it is very useful in areas such as marketing, scheduling, as well as robotics. So, that's all we have for this topic. Thanks for watching.